Give me a 3, 2, 1. Okay. Hello. In continuing in this saga of the Samantha frame fixture, I'm gonna set the fixture up on a bare table and go through that process because I think it will enlighten people exactly on what's going on here. So let's start. We start with our calculator, okay? And in our calculator, we have our given driving dimensions from our frame and some inputs from the fixture that we've made decisions about, and then some return values here. We're going to given some pinhole locations, and then some settings that we'll use on the fixture. And finally, we have a bullshit check down here where we can confirm the bottom of the head tube in a direct manner that will tell us if we've screwed something up, at least on that end. Okay, so I'm going to start, and it starts with the crank axis, and that is essentially going to be 0. And as explained in earlier videos, we've got these shoulder bolts. Put it right into the table here and down, and we can tighten that down. Okay, so for building the frame, that's probably plenty of strength in terms of tightening that down. If I was aligning frames, I might tighten this a lot better. So we've defined 0. Okay, now what I need to do is place my measurement pins. And as explained earlier, we have our measurement pins. This is a magnetic nut that sits underneath the table, and then our measurement pin will thread into it, and we're going to do that. But we need to know the location of the pin. And here we go. We've got XY pin placement for each one. So say the head is 5 and 7. So I'm going to go 1, 2, 3, 4, 5, 6, 7. And then from, this is 0, 1, 2, 3, 4, 5. Now, I've already got a few of these under the table, so I don't have to mess around doing this video. And I screw my measurement pin in. So that's the head. Now, we'll do the seat. And the seat is 7, -5. Wait, sorry. 7, -6. So 1, 2, 3, 4, 5, 6, 7. Here's 0. 1, 2, 3, 4, 5, 6. So there's the seat. Now we have the rear center. It's 1, -5. So we go up 1, and from 0, 1, 2, 3, 4, 5. And we go right here. Okay, so what's really cool about what I just did is because I've done this, I actually don't need the scales that I put on the side of the fixture to set the fixture. I just need these. The rest is integral in the unit. So let's start by going to the head tube assembly, and I'll put that on. Let me grab that. So let me put this down here, and I'm going to place it essentially so that my cosine pin is as close as I can get to the measurement pin, and that happens to be right where I put that down. Okay, now again I already have the nuts on the back side, so I just need to screw it in. That was just done for expediency in the video. And I'll screw all this stuff in. Notice how quick and easy it is to go from a bare table to a fully set up fixture. And let me do that. And we'll tighten this down. Boom. Boom. and there. Now, I'm going to put the other components on as well. This is the seat. And again, I'm going to back it right up as close as I can get it. There. No problem. Oops. There we go. Okay. Tighten this down. And notice I didn't have to look at the scales on the sides of this fixture. I just referenced there and just plunked it down as close as I could get it. I'll do the same for the rear center. Just as close as I can get it and in. Now, I am familiar with the fixture and the placement on the table, so that is helping. So there might be a little fuss for someone's very first time using it, but you can see once we know what we're doing, we can go from a full fabrication environment to a bicycle environment very rapidly. And I'll tighten that down. Okay, let me guess my timestamp. I'm betting I'm just under 8 minutes, and I've essentially fully placed everything on the table. So that's a pretty quick change from a flat table to now a frame fixture on a flat table. So now we're going to start setting it. So I have various dimensions over here. What I'm going to start with, I guess I'll do the angles for the head and seat tube. So as we can see here, our head can swing around. So I get from this page, let's go in inches just for fun, head tube 3.601. So I go in here, I move that out of the way, 3.601. Where, there we go. Good enough. Not moving anything. And then I'm doing a quick clamp there because we still might be sliding it. Let me do the seat. 3.693. Let's move that out of the way. 3.693. There we go. We're close enough. Within 1,000th. How's that? Okay. Put that there. Now we're going to go to some of the lateral shift that we have our slide here. So this goes back and forth. And we're going to use our measurement pin and the cosine pin. It has double duty. So in this case, the pin gap distance on the head tube, X, 1.933. So I'll just go out to 1.9. Oh, too far. Yeah. There we go, close enough. I think within 1,000th is fine, or a couple thousandths. We understand it's fabrication. So now that that's placed, or actually, let me just do all these. The seat tube X 2.243. We'll go over here. 2.244. So that happened to be in the right place, but you saw the method. So here's where things get a little funky. In the rear center, we're going to be looking at the rear center X. Let's do the pin to plate gap distance is 2.902. This is where these start coming in. That's 2.5 inches. So if I go 2.902 minus 2.5, it's 402. So what I'm going to do is measure, here, we'll get this up so we can get clearance there. So we're going to go, oh, look at that. We're right about there. We're just measuring that. Cool. We're in place, so I don't even have to slide that. But now we need to set the Y. And to set the Y, we have these two pins, but they're not on the same axis. They're slanted. Well, the thing is, our pin placement was given to us mathematically so that it tells us the rear center Y measurement of 2.385 between the pins. So I'll just slide this 2.385. Boom. Okay, so those are all placed. Now I'm going to lock down from the bottom side our this is going to hold, it's going to have a much greater moment on holding that. And then I just place this. You can see how it's helpful to have these magnetrons because we don't have to fumble with nuts or anything weird down there. It just slaps right in and holds, and then we screw it down. Okay, now we've set the fixture except for one last detail, where the head tube bottom is. So now I'm going to come over to this side of the fixture. And if you look, there's some details here. There's some pins right here. They might be hard to see over there. There we go. So we've got some pins, one here and one here. We're using the pin distance between those to set. This is at the pivot, and it's such a great distance. It's greater than my calipers. So I'm just going to subtract 5 from the dimension, and it gives me the dimension here of 11.598. So I'll take 11.598 minus 5, and that's going to be 6.598. So this makes everything a lot more convenient. And I can bring this up here, 6.5. And come on, there we go, that's good enough. There we go. The fixture is now set with calipers in approximately 18 minutes. Now, I have one last thing I can do. If you just stay there for a second. Oh, 2 more things. I apologize. So, we have to set the crankshell. So, in our print, we have 176.25 is where the base of the crankshell needs to be above the table. And I wonder if this is going to be worked out just so. We can use this for now. And 176.25 about that I can see. So that's the base of that. It's centering this shell. I've given it in its inputs. And then we drop our shell in there. And we clamp that down. And our shell is in place. We can even be fancy and put the head tube in place. And everything's really solid. Okay, now the last step is checking the fixture. It's telling me that the center of the bottom of the head tube to the center of the crank shell is 606.87 millimeters. 606.87 minus, let's subtract half the bottom bracket shell, 25.4, and that says 581.5. And now, if I measure from the outside of the bottom bracket to there, 581.82, I'm going to call that dead on. So there we go. That's how quick I went from a plain fabrication table to a precision setup for extremely high-end prototype level bike setup. I hope that gives some of understanding of how this comes up from the earth. Thank you very much.